Hi everybody, welcome to SeedWorld's strategy webinar, where today we're asking the question, what is the relationship between no-till cover crops and seed treatments? My name is Mark Zinkowitz and I serve as an associate editor for SeedWorld, and today I'm happy to be your host. Before we begin, I'd like to thank our sponsors, BASF and Syngenta, for their support. Today's featured speaker is Alison Robertson of the Iowa State University Extension. Panelists are Justin Clark of BASF and Dale Ireland of Syngenta, who will discuss what their respective companies are doing to innovate in this area, and they will also take questions. We will begin with Alison's presentation, which will take about 20 to 25 minutes, followed by Justin Clark, who will speak for around 5 minutes, followed by Dale Ireland, who will also talk for about 5 minutes. I then have a Q&A session scheduled, which will take about 15 minutes, depending on how many questions there are. We'll begin with our keynote speaker, Alison Robertson of the Iowa State University Extension. She has statewide responsibility for the management of diseases of field crops. She is a plant pathologist and professor and coordinates and provides leadership for corn and soybean disease diagnosis and management information, and also education programs for corn and soybean farmers and agribusiness professionals throughout Iowa. Alison earned her PhD in plant pathology from Clemson University in South Carolina. There's a lot more I could tell you about Alison and her achievements, but we'll cut to the chase and we'll get to the information that you're all here to hear about. Alison, thanks for being with us today to talk to us about the topic of no-till cover crops and seed treatments. The floor is yours.
Thank you, Mark, and thank you for having me this morning. Good morning or good afternoon to everyone on the line, and thanks for joining us. My lab has been doing a lot of work on seedling disease the past 5 or 6 years, and so I'm happy to share with you today some of the insights that we've had into the factors that affect the risk of those seedling diseases. And I'm just going to share with you a couple of things that we've learned and hopefully relate that back to our theme today of seed treatments in the context of no-till and cover crops. I'm just going to remind you, right, is a major reason why we use seed treatments is to protect crop stand from seedling diseases. And it's very important to you, to me, and to farmers out there that every single seed that gets planted reaches its full potential. And so hence the importance of seed treatments. So some of you on the line, I recognize some of the names, and so you'll know that I am totally obsessed with triangles. And the reason for that is because of, here we go, I'm getting my clicker sorted out here, is the disease triangle, right? And so all of my research is based around the disease triangle, understanding how that works from a disease perspective, and then how we can implement management practices that will mitigate that disease risk. And so just to remind you that we are only going to see seedling disease, since we're talking about seedling disease today, if we have a susceptible host out there, if the pathogens are present, and if the environment is favorable for that disease development, right? And so when we think about no-till and we think about cover crops, one of the first things that comes to mind when I think about that is the environment, right? And we know that no-till fields or fields planted to cover crops, when we're planting in the spring, when we're putting those seeds into the ground, those fields tend to be a lot cooler and wetter than a field that is not under no-till or has had some of the residue removed, or there is no cover crop residue sitting there. So we're thinking of colder and wet conditions. So some of the questions that we've been asking in the lab is, who are the pathogens and who is important in causing the seedling disease? And how do those pathogens, how sensitive are they to the fungicides that get used in seed treatment? How does environment at planting affect disease? And I'll touch a little bit on that. Many of you across the Corn Belt will know how variable weather can be at planting. And so how does that affect seedling disease? How do agronomic practices, so how do no-till, how do cover crops, how are they going to affect not only the pathogen, but how do they also affect the development of disease, and therefore how can we use seed treatments to affect that or to mitigate that disease? So one of the first things that we did was we worked with a group of pathologists across the state, and this was on a USDA study that was led by Brett Tyler, and Marty Chilvers actually led this part of the research, but we did the seedling disease survey across the Midwest. You can see there the map of all the locations where we collected diseased soybean seedlings. And then we isolated oomycete pathogens from those soybeans, and Marty's lab actually did the identification. And so from those diseased seedlings, we found 82 oomycete species associated with those seedlings. And when you consider that only 13 species to date had been reported as pathogens, there was considerably more diversity in the pathogens that we found than had been previously reported. Another thing to notice is that the species frequency fluctuated between years. So 2011, we had a very cool, wet growing season to start off with. In 2012, it was a much warmer and drier season. And so we can see that reflected in those bars, right, that you can see. So you can see up here that we have Pythium sylvaticum was always #1 across the years. But for example, here, the second pathogen, Pythium auropapillum, was very prevalent in 2011, much less prevalent in 2012. So if we go to Iowa, what I wanted to bring up here is that we have all these different oomycete species, and this is data from Iowa just showing the 9 fields that we sampled in 2011, and these different colored bars represent different fields. You can see the different species that we found there, but you'll notice that in field 1, for example, we found up to 11 different species of Pythium associated with those seedlings, while in field 7, we only found 2 species of Pythium associated with those species. And so that suggests that there are going to be different communities in different fields, or at least there are going to be different species associated with that seedling disease. And that could be because of a variety of different conditions, right? It could depend on soil temperature and moisture, and that could be related to what was the cropping history in that field. Was there a cover crop? Was it no-till? In most cases, there would have been corn planted because of the corn-soybean rotation in Iowa. But what about planting date? How would that affect? Was that soybean field planted earlier or later? Was the field 1 planted earlier or later than field 7? So there's a lot of factors that are playing a role in influencing the type of species that we see. Both my lab and Marty's lab went on to have a look at how temperature might affect the pathogenicity of these different species. And in Iowa, we worked with 4 of the most prevalent species here in Iowa. So you can see those here on the right-hand side of your screen. And what I'm going to show you is how did temperature affect pathogenicity. And so we used 55 Fahrenheit, which would be maybe a little cooler than normal soil temperature that growers would plant into. A lot of times they're probably planting around 60 degrees. And then 73 is just a lot of the work on pathogenicity has been done at room temperature. And so we wanted to be able to compare our data. At the bottom, you'll see I have soybean and corn. So these isolates came either these isolates were from soybean, but what we did was we inoculated both soybean and corn with them. And so I'm having a bit of problem here clicking, sorry. So this is Pythium tolulosum, and so if we look at just the data here, you'll see that Pythium tolulosum was highly pathogenic, okay, very high root rot severity at cold temperatures, but not very pathogenic at warmer temperatures. And if we look at the other species, you'll see that we saw an opposite effect with Sylvaticum. So Sylvaticum prefers much warmer conditions, doesn't like those cool conditions. Pythium oropapillum prefers cooler conditions, and there was no effect of temperature on Luterium. And so all of this information was is kind of suggesting that at different planting dates, or at different soil temperatures at least, let's not talk about planting dates because we know how temperatures can fluctuate, but at different soil temperatures at planting, we might be exposing our seeds to different members of the Oomycete community. And I'll get on to how that might affect seed treatment. So right here, this is work that was done by Anne Dorrance's lab, by Kirk Broders for his PhD work, and just showing that sensitivity to fungicide varied among the species. And so the fact that we're getting these different species prefer different temperatures suggests that at different planting temperatures, we're getting infection by different organisms. And then and loaded on top of this, now we have seed treatments, the sensitivity to seed treatments varying across those organisms. And so what does this mean in terms of placing seed treatments in the market? We took Kirk's study a little bit further. This was done by a PhD student in my lab who actually asked me the question and said, do you think that temperature could affect sensitivity to fungicides? And I just said, I said to her, no, I can't imagine why it would, but why don't you go ahead and have a look? And so Rochelle went ahead and she did typical fungicide sensitivity tests on the Petri dish, and this is for metalaxyl and ethoboxam. She used the 4 species that we'd been working with, and she tested sensitivity at 55 and then at 73. And we found a very interesting trend. So for Sylvaticum, and you'll remember that Sylvaticum prefers warm temperatures, okay? So at the warmer temperatures, Sylvaticum was less sensitive to metalaxyl. And then Tolulosum, which prefers the cooler temperatures, was less sensitive at the warmer temperatures. And so, and we saw the same trends with ethoboxam. And so this, the problem with these data is, what does this mean practically, right? These are lab studies, and this is something that Rochelle and I have struggled with. What does this mean out in the field? But it does suggest that some species may be, when they are stressed, so for example, Sylvaticum, if we're planting at, or let's take Sylvaticum, that would be okay. If we're planting in warm soils, and Sylvaticum is more likely to be a pathogen in those soils because it prefers those warmer conditions, and because it's happier and more content, it is less sensitive to that fungicide that's putting out there. And so that's one of the suggestions that we have from this data, but taking it out to the field and actually testing that hypothesis in the field has been a little bit more challenging. So I talked a lot about the variable weather that we've had, that we have here in the Corn Belt at planting. And this is some data from Northeast Iowa from another one of my students, small plot seed treatment trials actually. And what he did was, this is a trial that we planted in 2015. We planted the soybeans on April the 15th, or 16th, which is very early for Northeast Iowa. And then Mauricio monitored the soil temperature in those plots. And what you can notice is that when the soybeans were planted at 15 centigrade, which is about, about 59 Fahrenheit, So typically when a farmer would go in and plant, right, those soil temperatures are above 55, they're starting to warm up. But then what often happens in Iowa is we'll get these cold fronts that come through, and the temperature will drop down to very, very low temperature, around about 5. So we're dropping below 50 degrees Fahrenheit. And we know that that's stressful for that seedling and for germination and growth and development of that seedling. And you can see that throughout that period when we're planting, that we can have soils warming up, and then we'll get these cold fronts coming through, and that soil temperature just dropping. And so one of the questions that we asked is, could that affect susceptibility of these soybeans to seedling disease? And so Mauricio set up a really neat greenhouse trial where he imposed a cold stress period of 50 Fahrenheit for a period of 4 days. So we decided to do 4 days. And then what he did was he imposed that period at different times after planting. So at 1 day after planting, at 2 days after planting, 4 days, 6 days, and 8 days after planting, which, if you remember from the temperature data that I just showed you, is pretty much what can happen during a growing season. And so what we found out was that when we have cold stress occurring 1 to 4 days after planting, we had reduced emergence and considerably greater root rot severity in those seedlings. And so, and I have a picture here on this next slide just to give you an idea of what those look. So this is, these are the study that was done. We planted 5 soybean seeds into these cups that are filled with media, and we have a layer of Pythium inoculum in there, and then we're able to move the cups backwards and forwards between the growth chambers at the temperatures that we're set at. And so you can clearly see this is cold stress after 1 day. So remember, that would have been cold stress 50 Fahrenheit for 4 days. And so first of all, you can see the reduced emergence, and you can see that we don't have reduced emergence where there was no inoculum present. So this reduced emergence was not due just to some physiological effect on the seed. It was due to the Pythium inoculum. And then you can also see from the seedlings a lot more root rot where we had the Pythium compared to nice clean roots where we didn't have the Pythium. So, so with this information, we now know that those cold stress periods, that when we have these cold fronts coming through and a farmer has already planted his seeds, that his seed is at risk for seedling disease. So what would this mean in terms of seed treatments? What would happen if we put a seed treatment on under those cold stress treatments? Can that seed treatment mitigate the effect of that cold stress? And so Mauricio set up another growth chamber experiment, and this time he changed the periods of cold duration. So we had that 50 temperature range for 24 hours, 48 hours, and 96 hours. And so you can see here in this graph that emergence was reduced to around about 30 to 40% with our naked seed. However, when we treated that seed and imposed the same treatments, you can see that seed treatment mitigated that effect of that cold stress. And so it really protected that seed and helped with that emergence. I now like to go on and talk about some work that we've been doing with cover crops and seedling disease. And so we're going to shift over from soybean into corn now. But this was some research that we started a few years back with money from the Iowa Nutrient Reduction Center. And I've been working with Tom Casper here on this, and Tom's been working on cover crops for a couple of decades now. And we know that a lot of times when corn is planted after winter rye, that sometimes we see a reduced yield. And so there's been a lot of hypotheses put forward, and one of the ideas was, well, maybe it has something to do with pathogens, with seedling pathogens. And so Tom invited me onto the team to start working on this. And so, first of all, one of the first things that we did was we were able to show that winter rye was a host of corn pathogens. And so those Pythium species and those Fusarium species that cause disease on corn and can affect stand, those same species are able to infect rye. And when we take those pathogens from rye roots and inoculate corn roots, we can get just as much disease. So the next thing that actually Matt Backer did, who was a postdoc scientist working with Tom Casper, is he did some really neat work looking at rye and just mapping how Pythium populations changed over time. And he was able to show that as those rye roots senesce, that those Pythium populations increase. And so this suggests that that winter rye can act as what we call a green bridge, okay, for corn. So those pathogens are surviving on the rye. We kill the rye, the roots start to die, release all those pathogens, and then when we come along and we plant our corn, we're planting into these very high populations of pathogens, and so our corn is at risk for seedling disease. And so we did a couple of greenhouse trials and also some field trials where we actually looked at the effect of cover crop termination on corn seedling disease. And so you can see here that we had a no rye check, and then we also had rye that we terminated at different times before planting. And our hypothesis was that if there was a green bridge effect, that when we terminated the rye very close to planting the corn, that we would see more seedling disease in that corn. Whereas when we terminated the rye 2 to 3 weeks before planting that corn, that would allow time for those Pythium populations and Fusarium to decrease over time, so that when we planted the corn, we would see less impact of that that rye cover crop, so less green bridge effect. So this is some data from 1 year of the study, the 2015 year, I believe it was. Just so right here you can see that we saw a significant, we detected treatment differences based on when the rye was terminated. And so you can see that when the rye was terminated 10 days before planting or closer to the day of planting, that we had a lot more root rot on those corn seedlings than when we terminated the rye 21 to 14 days before. And if we had no rye, then we even had less root rot incidence. We were particularly interested in what the pathogens were that were causing this root rot. And so we collected samples of those roots and plated them out. And then we looked at the incidence of Pythium and Fusarium species. So how many of those roots did we isolate Pythium from, and how many of those roots did we isolate Fusarium from? And so you'll see that we detected a treatment difference with the Pythium. So we found a lot more Pythium when we had rye, and that rye was terminated before close to corn planting, compared to when we didn't have rye, that the incidence of Pythium that we detected was a lot lower. And interestingly, we didn't detect a treatment effect with Fusarium. So rye does not seem to play a role in increasing the risk of Fusarium infecting that corn. We went a little bit further with the Pythium, and what we wanted to do was we wanted to look and see if there were specific clades or specific species that were infecting the corn. And so this is just a table from our publication from Plant Disease, but a figure, but just showing you that in rye, when we have rye, we always find a greater density of Pythium clade B than when we have no rye. and we don't find any differences in the density of Pythium clade F with rye and no rye. So what are the implications of this? If you think back to Kirk Broder's work, he reported that sensitivity of fungicides varied based on species, and Marty Chilvers has carried on with Kirk Broder's work and is finding exactly the same thing, and finding that it may be related to clades as well. And so I know that his lab is just getting a manuscript ready to publish some data related to taking Kirk's study a little bit further on fungicide sensitivity. So the last thing that we're doing, just to finish up, is we are now starting to look at how cropping systems might affect pathogen populations and seedling disease risk. So we know that different crops are going to impact the populations, the communities, microbial communities associated with them. And so the questions that we're asking is, how are those communities affected? How does that affect disease risk? And then what does this mean for seedling disease management, particularly in terms of seed treatments? And so we're actually working with Syngenta, looking at some seed treatments and looking at some of those agronomic practices and how they might affect. So just in summary, we found that cold stress soon after planting increases the risk of reduced emergence, and that seed treatments help to mitigate that risk caused by that cold stress. Just a reminder that sensitivity to seed treatments does vary among species, and that we have some preliminary data to suggest that sensitivity is affected by temperature. And so as we move forward in this research, and we're learning a lot more about that seedling disease triangle and the different factors that influence that seedling disease, my challenge is to you is what we're learning about the cropping systems and about planting dates and temperature, etc. How is that going to affect seed treatment placement in the future? This is my last slide, but I would be remiss if I didn't thank the hundreds of people, feels like hundreds of people who have all taken part in this research. My lab, my colleagues at USDA and in agronomy, Ann Dorrance, Marty Chilvers, the OSCAP Extension Network, and the numerous undergraduates. And then also my funding sources are listed there. So thanks for having me today, and I'll be happy to take questions after the other gentlemen have talked. Thanks.
Thank you so much, Alison. Again, if you have a question for Alison, please type it into the chat box, and we will get to questions momentarily. I'd like to introduce now Justin Clark, who will be our next speaker. Justin is BASF Marketing Manager for Seed Treatments. He was named as SeedWorld's 2016 Future Giant of the Seed Industry. He's currently pursuing his doctorate in plant and soil science from Texas Tech University. He covers the BASF seed treatment portfolio, including seed treatment, active ingredients, inoculants, biologicals, colorants, and polymers. He also has responsibilities for some in-furrow technologies, and he supports foliar fungicides on peanuts and cotton. Justin, thanks so much for being here with us today, and I will let you take it from here.
Thank you so much. Thanks, Alison, for the great presentation, and thanks to SeedWorld for having us on today. Just to kind of give everyone a heads up about what BASF is doing in this realm of cover crops and seed treatments and no-till practices. You know, kind of some of the things that Alison touched on were really about those, going back to the disease triangle and having that disease inoculum and how it increases due to those residues in no-till cropping. And one thing that we know with those residues, yeah, they're great for soil moisture retention, agronomically for growers, but they're also putting that seed at risk because of those early season cold temperatures that can often be at planting depth up to 20 degrees cooler than the soil surface. So it's really important to protect against those cold die-off of those young seedlings. And also, one thing that we do know is anything of temperatures below 50 degrees Fahrenheit really delays seed germination and favors the seed rots and seed decays and those seedling diseases. So BASF, how we try to develop products to help growers capitalize on the soil moisture while not giving up anything to disease with those cold temperatures. Our line of fungicide seed treatments built on our Stamina platform for that F500 molecule that a lot of growers know for that same ingredient as what's in the headline, fungicide. One thing that we're excited to announce this week is the introduction of our Stamina F4 fungicide seed treatment for cereal crops. Just received EPA registration this week, so we're very excited about this for cereal crop growers. It's adding the Xenium molecule to our Stamina F3 fungicide to create a 4-way broad-spectrum fungicide seed treatment. We're very excited about this, and also that cold tolerance benefit that our Stamina line of products bring to growers. Under certain cold conditions, we see increased germination and increased emergence. So again, addressing both these issues of increased early season disease with no-till practices and also the increased cold injury, you're getting protection from those seed treatments that contain our F500 Stamina molecule. I'm very excited about our Stamina F4 product and what it'll bring to cereal crop growers. With that, I'd like to turn over to Dale now. But again, I'm very excited about this new product we have coming to the market. So stay tuned for more details over the coming days and weeks. Thank you.
Thanks so much, Justin. Last but not least, we'll hear from Dale Ireland. He's Syngenta Crop Protection Technical Product Lead for U.S. soybean and corn. He plays an important role in profiling active ingredients for disease, insect, and nematode protection. Before joining Syngenta, he worked for DuPont Pioneer for 14 years as a research scientist, and he held international management positions. He earned a bachelor's in agronomy from Texas A&M University and a doctorate in crop physiology from Iowa State University. Take it away, Dale.
Thank you very much, Mark. I appreciate the opportunity to be a part of the Seed World Strategy webinar. And thanks to Alison also and to Justin. In my responsibilities at Syngenta, I did quite a bit of field work with seed treatments on both corn and soybean. And certainly we noticed that in cooler, wetter conditions, certainly that slow both corn and soy emergence, there's a greater opportunity for disease infection. I think that I think most people are very much aware of this, and yet reinforcing the fact that when we use cover crops and no-till to conserve soil, reduce erosion, those are good things. Those are very important things for long-term management of land and retaining soil fertility. We do have some other issues that may increase management, and that really is many of the things that Alison was talking about when she was discussing much of her research. That when we do some of these practices, we increase the opportunity for further infection, and we just need to be cognizant of the fact that seed treatments play a role in helping manage that increased pathogenicity of that environment. So when we have slower emergence of crops due to cooler, wetter conditions, we have a greater opportunity for that infection to occur. But yet, on the other hand, we know that early planting increases our opportunity for higher yield potential in both corn and soybean. So we're kind of caught in a catch-22 there. But we know that using a good high-quality seed treatment can mitigate those risks to a large degree, that some of those issues that are related to disease infection. And that really brings me to something that my colleague Justin on this call mentioned earlier, and that is the importance of specific active ingredients. Not all seed treatments are created the same. And while I'm not going to spend a lot of time today on specific Syngenta active ingredients, I would just challenge everyone to think about what each individual active ingredient brings to the party. And by that I mean just because a seed is colored with a pigment or a dye doesn't mean that it has a specific protection profile. It just merely indicates that it was covered with a dye or a pigment. So in other words, not everything's the same under the hood of a car just because it's a car. And I would just challenge everyone to study and understand better what different active ingredients bring to the table, and especially under these challenging conditions of they're brought with no-till situations, with the cover crop situations. The active ingredients that you're using in your seed treatments are ever more critical, protecting the yield genetic potential of your seeds. So at Syngenta, we discover, we develop, and commercialize seed treatments. We've been doing this for nearly 40 years. It is the lifeblood of Syngenta, and we have a rich pipeline coming. We have a new Pythium compound that we're working with Alison Robertson on in some of her work at Iowa State. We're also doing some work with Ann Dorrance at Ohio State, working with this molecule, this new molecule we expect for late 2019 introduction, a new mode of action for oomycete pathogens, including Phytophthora and Pythium. So we're very excited about that. It has very strong characteristics when combined with the rest of our active ingredient portfolio. So I want to thank SeedWorld. I want to thank Mark for hosting, Alison and Justin for participating, and my opportunity to be able to share just a few minutes on the call today. So I'll turn it back over to Mark, and thanks again.
Thanks so much, Dale. We're now going to move into the Q&A portion of the webinar. We'll open it up to questions from our audience. Again, if you have a question, just type it into the chat box, and please let us know who it is directed to. Alison, can you recap for us the study you did from 2011 to 2013 on soybean seedling disease and why it was so important to your research?
Can you repeat that, please, Mark? Sorry, I missed the first half.
No problem. Can you recap for us the soybean seedling disease survey you did from 2011 to 2013 and why it was so important for your research?
So that survey was, as I mentioned, was part of a big USDA grant that was actually focused on Phytophthora sojii. And one of the questions that we had was how important was Phytophthora sojii as a seedling pathogen within the North Central region. And so we started doing this study and and collecting all of these disease seedlings. I want to stress that they were disease seedlings, and then identifying the pathogens associated with them and finding out that really Phytophthora sojii is not that important as a seedling pathogen as it was 20 or 30 years ago, but we now have all these different Pythium species that are coming in. And so, there were 83 different oomycetes, I think. So obviously not all of those are going to cause disease. We know that there are some oomycetes that are good biocontrols. So what we wanted to find out then was, which of the ones are pathogenic, and then how important are they economically? One thing that I didn't mention, but if you go to the papers that were published from the study, which are both in Phytopathology in June 2017, I believe, was that we found that the species varied by latitude as well, and that is probably because we're getting different plant temperatures at planting, right? In the southern it's going to be much warmer than in the northern areas. So I mean that study kind of opened up Pandora's box, I think, and that as we started to dig deeper into understanding each of these species and how important they were and what are the conditions that favor them and how do they respond to seed treatments and then finding out that rye is selecting, that certain members of the clade B species are more predominant after you have a rye cover crop. So, I mean, there's just a million questions in there. I should be busy for the next few years. I hope I answered the question.
No, that was great. Yeah, no, I imagine you'll be very busy. In regards to all the data and the significance of planting data, and perhaps all three of you could weigh in on this, in this age of big data, as we seem to have more and more data coming at us all the time, what is the significance of planting data in your work, not just in research, but also in new product development as well, Dale and Justin? I imagine this new data coming is of huge benefit, but it's probably also a really big challenge to sort of wade through all that and figure out what's what, I suppose.
So I'd be happy to weigh in. This is Dale Ireland. When it comes to collecting data, certainly with the new technologies and remote sensing technologies that we have today, it's been very valuable to us to understand better just what Alison was talking about, these temperature cycles, or let's call them microcycles within the growing region. Rather than just depending on some macro kind of data from a weather station or some other temperature probe miles away, possibly having multiple sensors within the planting area, collecting incredible amounts of data based on time and seeing how these temperature cycles occur. And certainly we've seen many of the same things Alison was talking about as far as we all know the springtime's an extremely variable time of year. I mean, you don't know whether to bring your jacket in the morning or to keep it on later because you don't know what type of weather you're going to have. Cooler, wetter in its cycles, with warmer, drier. And certainly that type of data has allowed us to analyze our data in unique ways and provide us greater understanding of why we see what we see.
I'll weigh in quickly, Mark, and just to mention that I think one of the challenges about the big data as well, at least from my point of view, is I sit here in my ivory tower and I need to remember that sometimes some of the things that we do are maybe not practical in terms of farmers or in terms of, in this case, the seed treatment industry, right? So, Dale mentioned how different active ingredients work against different species, and we're learning that all the time. And so it's really important to know what those active ingredients are. And then I talked about how you can have a field with 7 different species of Pythium, right? And that's just Pythium. We haven't even focused on the Fusarium yet, or the Rhizoctonia in there. And so, but obviously we can't do a custom seed treatment for just one field, right? And so I think that that's one of the big challenges for me about this big data is it's really cool to answer academic questions and to have this ivory tower mentality, but I have to keep getting out and putting my boots in the field and thinking, okay, but practically what does this all mean?
From our perspective at BASF, kind of echo that is as we're developing new products and putting them to the test in the field across numerous different climate conditions and temperature extremes, we really just want to know what those active ingredients are doing and where they are strongest and best suited. And that's really how we go forward with making our selection on products that we put into the marketplace, where we know that they're providing a grower with the best solution across all geographies and across this specific geography where we're launching that at. So I think that's one thing we really pride ourselves on, is really putting these products to test all across the board. And again, like you said, planting earlier is getting to be a bigger push all across the country. So really for growers to pay attention to their fungicide active ingredients that they're putting on and the benefits they're getting from that is very important.
And that leads me to my next question. Justin, I believe it was you who mentioned earlier, it may have been Dale, that not all seed treatments are equal and that people really need to do their research. Justin and Dale, can you give us some pointers on what people can watch out for, what resources they can use to really, if they're looking into a new product, to really know exactly what they're getting and maybe more importantly, exactly what they need? I imagine there's quite a range of products out there. So how can people really wade through those very deep waters?
Well, I would say, we've got one on the phone here with us today. Rely on those unbiased university extension personnel because they do put a lot of these products to test across different geographies. Work with many universities, most land grants across the country, no matter the crop. So again, I think pay attention to those resources and what they're putting out, and also, we're producing a lot of good, beneficial information for growers as well, because we're trying to be, again, all the time as unbiased as possible. So we're putting out a lot of real-world data and putting out and putting these fungicides to the test of these major diseases all across the country, no matter if it's peas and lentils in North Dakota or peanuts in South Georgia, right? So something that we're always keeping an eye on. And but yeah, I would say that relying on those land grant universities.
I'd certainly reinforce what Justin just said. I would also add that ask questions. In my experience in agriculture for many, many years, it surprises me the lack of interest in different active ingredients and seed treatments. And by that I mean, you don't have, generally, it's been my experience, a grower come into his local provider and say, I want a herbicide sprayed on my field. I have weeds and I want a herbicide sprayed. But yet they'll have a specific active ingredient. They'll know the weed species spectrum of the field. They'll know the herbicides they want, or their consultant has talked to them about this. Very on top of that, typically. And when it comes to a seed treatment, for some reason, it's the only decision point, like for instance on soybeans, you want that treated or not? Maybe there's an option to have an insecticide along with a fungicide, but generally it's just, do you want it treated or not? And nobody ever talks about or asks the question, so what are the AIs? What is the spectrum? What are the rates? These kinds of things. It's kind of a black box when you think about seed treatments. And I would just challenge folks that a seed treatment's not a seed treatment. They're all very different. There's as many active ingredients in seed treatments, if you look at the entire spectrum across crops, as there are herbicides. It's remarkably diverse. So I would just challenge a bit more curiosity in that area.
Great. Well, thank you very much. That's actually all we have time for today. So I just wanted to thank our speakers, Alison Robertson, Justin Clark, and Dale Ireland, for taking the time to join us and to share their expertise. I also want to thank our sponsors again, BASF and Syngenta. As always, thank you so much for participating today, and I hope everyone's found this information of value. And again, thank you to our sponsors, BASF and Syngenta, for their support. I'd also quickly like to thank our team working behind the scenes for all their hard work in making this a very successful event. Julie Deering, Kyle Jadawani, and Teresa Kurdziewicz. Again, this presentation will be available on our website at seedworld.com in both a video and an audio format. Thanks again, and we hope you have a terrific day. This is Mark Zinkowitz of SeedWorld signing off.